So here we are, three geeks. We're going to talk about some technology. We have a half hour, and that's what we're going to do. And I am obviously not the smart one here. I appreciate you guys putting up with me. But I've been just talking with these guys, and the things that they're doing are quite remarkable. And so what's cool about them is one is from the absolute West Coast, and the other is the absolute East Coast of the United States. And what you're going to do, you guys, you're going to fill it all in from the middle. But Utkarash is actually can see the Apple headquarters, the new Apple headquarters being built from your school, is it?
Yeah, it's right next to my school.
Yeah. And Kenneth is from the Upper West Side of Manhattan. So anyway, what they're going to do, and what both these guys, I guess they share something very common. They care about somebody, and they see technology as a solution. And so they're going to share their ideas. And what I'd like them to do, Kenneth, I'd like you to go first.
Okay.
And give us your 6-minute micro TED Talk.
Sure.
And then Utkarash, you can go next, and then we'll just talk.
Awesome.
All right.
Awesome. So I'll go get the clicker.
All right.
Awesome. We good? Okay, great. So first, I just want to say it's such an incredible pleasure and honor to be here at the CES. Every year coming here, seeing the incredible amount of innovation that's going on just really blows my mind. And being here in particular at the Digital Health Summit, it's really great to see all the innovations that we're making in order to make the world a healthier and happier place. Growing up in a family with 3 generations, I've always been very close to my grandfather. When I was 4 years old, my grandpa and I were walking in a park in Japan, and at one point he suddenly became completely quiet, and I could tell from the blank expression on his face that he was lost. It was one of the scariest moments I've ever experienced in my entire life, and it was also the first incident that informed us that my grandfather had Alzheimer's disease. Over the years, his condition got worse and worse, and in particular, he frequently wandered out of bed at night. One time, we found him lying on the bathroom floor with blood trickling out of his head. It turned out that as a result of his wandering, he had fallen down on the bathroom floor, and we hadn't noticed him for over 2 hours. Naturally, we were very concerned about my grandfather's wandering since we knew it could pose very serious consequences for him. My aunt, kind soul that she is, volunteered to look after my grandfather day and night and had to stay awake all night to keep an eye on him, and even then often failed to catch him leaving the bed. So I became very concerned about my aunt's well-being as well as my grandfather's safety. I looked in the market at the time and couldn't really find any existing solutions, so I decided to take it into my own hands to find a solution to the problem. But how? One night, I was back home for Thanksgiving break, and I was put on night watch for Grandpa. The moment his foot landed on the floor and I saw him stepping out of the bed, I saw the answer to my family's problem. Why don't I put a pressure sensor on the heel of my grandfather's foot? As soon as he steps onto the floor, the pressure sensor would detect an increase in pressure and then wirelessly send an audible alert to my aunt's smartphone, waking her up. That way, she wouldn't have to stay awake all night worrying about my grandfather's wandering. So I immediately put my ideas down into a plan and realized that my task was much more difficult than it had initially seemed. In particular, I realized that I faced 3 major obstacles. The first was creating a wearable pressure sensor that was thin and flexible enough to be put under my grandfather's foot comfortably and would also be reliable enough to accurately detect his wandering. The second challenge that I faced was creating a wireless low-power circuit that would essentially be able to send a signal to my aunt's smartphone. And the third challenge that I faced was creating a smartphone app that would transform my aunt's smartphone into a remote monitor. Now, none of this was easy. And weeks of painstaking, back-breaking effort would often lead to little progress and much frustration. I tried to tap into every possible resource, reaching out to experts, leading conversations on online tech forums, conducting extensive literature searches. I remember spending the entire summer of 2013 just struggling to connect my smartphone app to the wireless circuit, just focused on that one particular problem. But with a lot of dedication, thankfully, I was able to integrate all those components together and create 2 prototypes. The first is a sock with a sensor embedded inside of it, and the second is a reattachable sensor assembly that could be placed anywhere on the patient's foot, heel, shoe, sock, you name it. I tested these 2 prototypes on my grandfather for a period of over 12 months, and they were able to successfully detect 100% of the known cases of his wandering. They were really able to bring a lot of peace of mind to my family and also protect my grandfather's safety. He didn't suffer any falls since then. I was encouraged by these results, and I decided to test my device at several care facilities over the summer of 2014. There, I learned that the burdens faced by my family were part of a much larger societal challenge. In fact, as many of you may know, and we discussed this yesterday, 60% of the dementia patients around the world actually wander. And in fact, when I was doing this research, I also realized that a lot of elderly also suffer from fall injuries. In fact, 2.5 million seniors are treated in the ER for fall injuries each year. And falls cost the US $34 billion, and that doesn't even count the significant emotional and mental costs to caregivers and families. So I was incentivized to form my own startup because I really wanted to deliver my solution to the millions of families out there who are suffering from this problem. And SensaRx, which is the startup that I came up with, is essentially focused on delivering care innovations, focusing on patient safety, and delivering them to the millions of patients worldwide who are suffering from wandering problems and just other healthcare challenges in general. The beta test that I was doing also provided me with a lot of good feedback. I learned that a lot of patients don't want to wear socks to sleep, so I worked on a non-sock solution, and I was actually able to come up with something new called the button sensor. This button sensor works by detecting changes in body position, but instead of having me show you it, I wanted to invite a good friend of mine up to the stage today. This is Adam, a snowman who is wearing the sensor. Not sure how much you can all see this, but he's wearing the sensor right here on his clothing, and let's say that he were a patient lying down in the bed. Let me get my caregiver smartphone out. And as soon as Adam starts to rise out of the bed, the sensor detects a change in body position and sends an alert to a caregiver smartphone right here. You can't really hear the alert that well right now, but as he gets out of bed, it's supposed to send an alert to a caregiver's smartphone, and that immediately triggers something that enables the caregiver to check on the patient and be able to make sure that the patient is back in bed. And I was also able to implement inside the sensor a short-range to long-range system, essentially a gateway that allows the caregiver to receive an alert no matter where they are. So even if the caregiver is miles and miles away, they can actually still monitor the patient's wandering. So over the summer of 2015, I tested this device again at several care facilities, and those essentially validated many of SafeWander's unique features and benefits. You can monitor patients from any room. With the new attachment method that I created, you can securely attach the sensor onto any clothes worn by the patient. You can even monitor multiple patients using one mobile device. And a lot of existing devices actually ring on the patient himself, so the patient gets disturbed as a result of the loud alert. But SafeWander sends an alert to the caregiver's smartphone, which doesn't disturb the patient or anybody else nearby. So SafeWander, the button sensor that I created, is actually the world's first wearable sensor system that sends an alert to your caregiver's smartphone as soon as anybody gets up from his or her bed. It's useful for not only detecting the wandering of dementia patients, but it's also really useful for preventing patients from falling. So lots of seniors are at fall risk, as I mentioned earlier in my presentation, and because this sensor sends an alert to a caregiver's smartphone, before the patient's feet even land on the floor, this could be very useful for preventing falls, and if not that, at least reducing response time to falls. Compared to a lot of existing products in the market currently, SafeWander does provide a lot of unique advantages. For example, you have a long wireless range on this product that a lot of other technologies do not. You can carry one monitor for multiple patients, and again, it's just a much better solution than what currently exists in the market. So this has been a long journey since I first got lost with my grandfather in that park about 13 years ago. But it's not a journey that just involves me and my grandpa, and this journey isn't something that ends with the button sensor. This is a journey that, in my opinion, involves all of us. It involves the entire aging population. It involves all of us innovators and technologists and engineers, because we're the ones who can make a difference with technology to change the lives of the elderly and change the way that we view the problems to the aging population right now. We have the tools in our hands in 2015 at the CES, with all the technology and innovation that we have in our hands now, to truly be able to tackle these problems head on and be able to solve many of the problems associated with our aging population. I know that we can do it, and thank you so much for your time. Utkarash?
Nice.
Really impressive work, Kenneth. Had a good time listening to that presentation. So just first off, I'd like to thank the Digital Health Summit and Ms. Gilbert for giving me this opportunity to present in front of you guys. It's a huge honor to be able to show you what I've been working on. So Parkinson's disease affects 10 million people worldwide. and the condition manifests itself as a movement disorder. So therefore, it prevents Parkinson's patients from having complete control over their body movements. These motor symptoms that result from the disease cause significant problems for Parkinson's patients on a regular basis. Okay, just give me a second.
If you'd like, we can reprogram your whole system here.
Oh, there we go.
There you go.
All right. So the current diagnostic procedures for Parkinson's disease is purely qualitative, meaning that Parkinson's physicians have to sit down with their patients to visually recognize motor symptoms. And this makes it subject to extensive human error. And lastly, current diagnostic procedures and appointments are very infrequent, causing the Parkinson's physicians it makes it very hard for these Parkinson's physicians to get an accurate representation of how their patients' motor symptoms are progressing on a daily basis when they're at home. So that's why I built OneRing, which is an intelligent tool for monitoring Parkinson's disease. The wearable ring captures movement data for an entire day and analyzes this data using our signal processing-driven machine learning algorithms, and uses this to diagnose the severity of motor symptoms at each and every hour of the day in order to create these smart patient reports that a physician can read in order to better prescribe medications. So the system has two major components, the wearable ring and our iOS app running on an iOS device. Using low Bluetooth energy technology, the patient can pair their ring to the iOS device, wear their ring, and start their day with the tap of a button. Then OneRing captures movement data in a very passive manner, which allows Parkinson's patients to go about their day freely and not really have to worry about their diagnostic tool on their finger conducting diagnostics. So when they're ready to sleep, they can take off the ring and go to sleep and press end day. This allows our machine learning model to conduct its analysis. So the core research behind OneRing was developing and training these machine learning models in order to automatically classify the stage of Parkinson's disease motor symptoms. So along with our signal processing algorithms, OneRing analyzes this raw acceleration data that it captures in order to predict the severity of motor symptoms at each and every hour of the day using random forest modules. These classifications generate a smart patient report highlighting the date stamp, the various timestamps, and the hourly movement severities whenever the patient was wearing their ring. With this report, it's additionally sent to the patient's physician, and the physician can read these quantified results in order to accurately prescribe medications by looking at when their patient's tremor or their motor symptoms intensify. So overall, OneRing provides an intelligent way and an entirely new way for Parkinson's patients to interact with their physicians. And it really works towards providing that vital quantification to the disease. Just quickly going into how I got the idea for this project, I actually stumbled upon a YouTube video a couple of years back of Muhammad Ali lighting the Olympic torch in 1996. And what I saw in this video was Muhammad Ali having these rapid tremors that was preventing him from being able to actually light the torch in a very simple manner. So I became very interested in wanting to learn more about his story. Why is he having these problems with his motor symptoms? So I figured out that he has Parkinson's disease. And another example was when I was watching Back to the Future, and Michael J. Fox has Parkinson's disease as well. And after watching the movie, my dad told me that he has the condition. So I became really interested in wanting to read more about the disease, read how these motor symptoms affect the patients on a regular basis. And this pushed me to build OneRing, build something that can help people on a daily basis. So therefore, I began my machine learning research when I was 14. And since then, I've been working on them. And a pretty interesting fact was that the database that I used in order to train my algorithms was actually sponsored by the Michael J. Fox Foundation. So I found that to be pretty cool. And so using signal processing techniques, I was able to extract the most important features from daily movement data and put these into a form of, into multiple trends that could be fed into a random forest classification model in order to predict the severity at each and every hour of the day. So as I continued working on my machine learning algorithms in the back end, I was able to develop a first prototype. And over my summer break, I went to Parkinson's Institute, a local Parkinson's Institute, where I just went for volunteering work. But over there, I actually got firsthand interactions with Parkinson's patients, and they allowed me to actually conduct clinical validation of OneRing. And over there, I was able to talk to the physicians and their patients and see what is the best device I can build in order to help Parkinson's patients and their physicians to better alleviate their patients' motor symptoms. And I tested this device, and I was able to build a much more impressive machine learning model, and I developed an iOS app and published it on the iOS App Store. So these are the various prototypes that I've built. You can see at the beginning it was just an armband using very simple 3D printing technology. So I just wanted to be able to test my machine learning models. But over time, as I got more advanced in 3D printing using SLS technologies, I was able to develop the ring model, and that's what I'm wearing on my finger right now. But we're also working on a flexible technology, so we're able to make a one-size-fits-all ring, and that's what we're working on right now. So I'm really excited to announce that we've launched a Kickstarter campaign for OneRing. It's live on the Kickstarter website right now. It'd be great if you guys could check it out, because with the funds, we're going to be developing multiple rings and deploying them to the local institute where I worked at. And we're going to be improving the research behind it and also seeing how they benefit physicians and Parkinson's patients on a regular basis. So please check it out at www.oneringforpd.com. And here's my contact information, and definitely check out the website. Thank you.
You guys did a great job.
Thank you.
What's kind of moving to me as an older person is how both of you were driven by someone you care about, and you both had this real passion to help somebody, and kind of made me sad, and it was very touching. So any myth that the youth are calloused and don't care, I think that's shattered. I'm interested in some of the failures you had. I mean, it's using technology is tricky, and I know you both devices shared low energy Bluetooth, and probably batteries. You learned a lot about batteries and sensors. What are some things that didn't go right?
Well, I feel that at the beginning, it's that you need to have something that you can really test your research out with. And that was really hard for me to figure that out, because I never had any experience in electronics, PCBs, and all that stuff. So basically learning more about the electronics was the hardest part. But after a while, I was able to read a lot of blogs and tutorials online, which is very useful in order to quickly grab information. And I was able to figure out what is the best electronic I can use, how I can do 3D printing in order to test my device, make it a compact wearable that people can use. So that was my first problem.
Is it safe to say that you guys are sort of YouTube schooled?
Yeah, kind of. You can say
you
that.
learned a lot, and you had a problem. You'd go out and say, okay, I need to learn about plastics. All right.
Yeah, definitely. And I remember one particular summer, I was trying to connect the smartphone app to the sensor circuit. I was focusing the entire summer around that one specific problem. And I remember just one day having 200 errors in my code, 200 errors. And that challenge just seemed insurmountable to me. How was I going to fix these 200 problems in my software? I just didn't think I was going to do it. And during moments like those, I think people really feel like they want to give up. But I think what really motivated me to push forward and to continue working on this problem was my personal connection to my grandfather, and just seeing the devastating impact that his wandering was having on not only him, but also my aunt, really made me want to create this technology to help him. So
technology is nothing without context.
Yeah. But I think to solve those problems, definitely, I used the internet a lot. And it's amazing how helpful just YouTubing a problem sometimes, or even Googling it, really is. And you can just pretty much find a solution to any problem out there.
What were some of your big breakthroughs? I mean, was there a moment where you're like totally stumped and like, I figured it out? You want to share any of those?
I feel that for me it was more on the algorithm side, because I was spending a lot of nights trying to bring up the accuracies of my machine learning model. So in order to do that, you have to really put in a lot of effort into finding the most important features so you can represent the data in the best way. So once I was able to do that, I saw that my accuracies were reaching up to like 75, 80%. So once I reached that, I was really, really proud of myself and really excited to continue working on it.
One breakthrough that I experienced involved my grandfather, and my grandfather and I used to sing to each other, so that's how we bonded when we were very young before he got his diagnosis with Alzheimer's. And I remember with almost perfect timing, just about at the time that I was ready to give up that summer, I heard my grandfather singing, and his once towering voice had been muted to this indistinct whisper, and he stumbled over many of the words that he once knew. But instinctively, I placed my hands over his fragile palms, sort of like he would put his hands over mine when I was very young. And in a moment of sudden recognition, I remember that his grip tightened, and I knew that he still remembered me. And it turned out that years of Alzheimer's might have eroded my grandfather's memory, but not the enduring love and the bond that we shared for each other. And at that moment, I realized that even though I couldn't reverse my grandfather's condition, at least I could keep him safe with this sensor. And that just galvanized me to push forward and continue working.
Now, we are close enough to California where we could do a group hug if you'd like. Is that all right with you guys? It's so moving. I mean, this whole idea of the context is everything. And so one thing I will say is there's a lot of grandparents that are very proud of both of you and your generation. And so I know I am. So let's talk about college, my friends. Have you taken the SATs, and how's that going?
I haven't. I'm pretty young still, so.
I know there's a lot of schools that are interested. Kenneth?
So I'll be going to college next year. I took the ACT. Yeah.
And where are you going?
Not pleasant. I'm going to Harvard next year.
Okay. I've heard of it, Harvard.
It's a small college, somewhere next to Boston, I hear.
Yeah. There's a friend of mine at Carnegie Mellon, Drew Davidson, who says we need to teach people to fail faster. And I think that both of you have already had a lot of these opportunities and huge challenges figuring out the technology. The other piece, I know, Kenneth, you've thought about that from your slides, is the business model.
Yeah.
You're the funding it, getting the contact with the Parkinson's Foundations obviously was huge. What have you learned from the whole business side?
I feel that as I launched my Kickstarter, I had to take far more things into account. I had to make a website. I had to make sure that the presentation was very clean, and that so.
It was, by the way.
Thank you.
Both of these presentations were squeaky clean, right? I mean, you're like, these are high school kids, all right? Oh, hold on. Check out this tie. Look at that.
Thank you.
I mean, really, it's awesome. Yeah, so on the money side, I'm sorry, I interrupted.
Yeah, so with the Kickstarter, you always have a video that you have to make. So in order to make that video, I decided to make sure that it looked very impressive. And also, since I was on a high school budget, I had to improvise and make a very hacky solution to that. So I basically made my entire living room into a studio using white papers, clamp lights, and I was able to make an infinite white background video, like how Apple does it. And I live pretty close to Apple, so I'm pretty sure that's where I got the inspiration from. So
yeah, and it's really cool that you're so close to Apple. But yeah, I definitely saw that. Kenneth, any thoughts about cash?
Yeah. So someone once likened the experience of creating a startup based around a tech prototype as when you make the prototype, you get to the base of Mount Everest, and then when you successfully commercialize, you've reached the top. So just finishing an initial prototype of the button sensor was just sort of getting to the base for me. I remember when I was sort of starting out, I realized that there were so many things that I had to do in the world of business that I hadn't thought of. Like, I have to file taxes, and I have to make a business plan, and I have to think about how to raise capital. I mean, these are all things that you have to go through when you're making a startup, and they're all obstacles that you have to overcome. So it's a pretty difficult learning process, and there's certainly a huge learning curve, but it's been a blast going through this whole process and really exciting stuff.
And it's also real.
Yeah.
Your challenges are real. And the money that you can make is real, and that's what sort of built CES and the whole commercial. We're in the middle of it right now.
Yeah.
Can't you feel it? It's
yeah.
like, it's really cool. You guys have both had very polished presentations that you've delivered solo. You've never done it together. And I'm curious, you're both, you share a lot. Did you have any questions for each other or comments about each other's presentation?
Well, one thing that I found very interesting about Utkarash's presentation was the fact that he was inspired by just this one moment of Muhammad Ali struggling to light the torch. Right. For me, it was this personal story where I was, very close to my grandfather, and this sort of arose out of a personal need. But Utkarash, I'm guessing, was just watching TV one day and saw this problem, which I find really incredible and inspiring too. That you can just be inspired to create this incredible technology from just one moment of watching TV one day and saying, hey, there's a problem and I can solve it.
Yeah, that's definitely there. It just came out of the blue for me. But when I was also working at the Institute, I was planning on, do I continue on this project or do I stop? But when I met those Parkinson's patients, I saw how much the actual condition affects them on a daily basis. And they told me about that they were very adventurous, they were outgoing, but now they can't even drive a car. So it was really touching that I want to build something that maybe can somewhat help them with prescribing medications and all that stuff. And for you, definitely, I'm sure that your device can really help a lot of people. So it's very impressive that you've been able to build something for your grandfather.
Thank you
for that. So.
One other question that I had too was also where you were able to get a lot of your computer science expertise. I mean, hearing about the algorithms was very impressive, and I'm sure it required a lot of research. And I think we alluded to earlier, using YouTube as a tool for sort of being able to solve problems. But did you take any computer science classes at your school? Did you take anything outside of school?
I think it kind of bloomed up from science fairs. So whenever I've done science fairs, I've started like when I was in 2nd grade, but really doing more research was in 6th grade. So I really started wanting to do a lot of algorithm work, building wearables for healthcare purposes. So that's where I got into the computer science. I started doing some simple algorithms in Python, but after that, it really bloomed into like machine learning and artificial intelligence. But it's definitely that science fair community where you go into doing your research and then you build a prototype off of what you do. So that's where it kind of, the computer science came into play.
Yeah, one thing I noticed is that both of you, people forget how much work there is in the actual software side. That it's nothing tangible. It's collecting the data is much more straightforward. What you do with the data is where the magic happens. Is that an accurate statement?
Yeah, I think that's definitely true. And a lot of work does go on in the software. And I remember when I was starting out with this project, I was sort of like a caveman fiddling with sticks. I wasn't really sure, how to do any of it because I didn't really have any computer science know-how. I mean, I could write like an if-then statement. That was pretty much it. I really couldn't do anything with code. And so it was just an incredible learning process that required a lot of resources and also reaching out to experts too. And one of the great things about working on this project was that I was able to do a lot of this research on my own without having a lot of help from school mentors. It was just something that I was able to take on because I wanted to help my grandfather. So that was sort of arose out of just a personal need.
Hey, I got a question for you because I want my kids to grow up like you guys. All right. What advice would you give to, like a little kid right now? Or what did you do when you were a little kid that helped you get to this point?
I say just start off with a really big passion for something, because when you're interested in something, you're always going to push yourself to continue working for it. So as long as you're interested in something, it doesn't really have to be computer science. It doesn't have to be like developing wearables or what we're doing. But it's definitely having a passion in something, and then you're really going to pursue it.
Well, Sergey Brin used to play with the Commodore 64, program in BASIC, right? And he learned the magic of code, and I think that's something shared by people like Bill Gates and so on. What was yours? What did you guys do when you were like really young? Your first experience with code?
Yeah, great question. I mean, I grew up in a family with civil engineering professors for parents. So when I was really young, it was like 5. I feel old saying that when I was really young.
Yeah, just when I was a kid.
When I was a kid. stroking my beard. When I was 4 or 5 years old, I would go to my parents' labs and I would sort of tinker with the gadgets there. And I remember that really sparked my interest in technology from a very young age. And growing up in a family with 3 generations in particular, I was also very close to my grandparents. So I just sort of saw a natural link there between using technology and also engineering. And one question that I also had for Utkarash, in what way do you think that us youth specifically are empowered to be able to use technology to help the aging population? I know it's sort of a broad question, but do you think that youth has a special role in that whole equation?
I think definitely, because we've had our interactions with our grandparents. We've really seen how, whether if there's some condition that they have or something that we want to do personally for them, like for your story, how you did it for your grandfather. But definitely, we have the resources right now. We have the internet. We have everything where we can just take in information. And since, yes, we are younger, so it's very easy to learn more things very quickly. So it's important that when you're a kid, you're able to develop things using that information that you quickly gain through the internet. So,
guys, real fast, what kind of gadget do you have in your pocket? Apple, Android?
Yeah, right now I have the iPod, but I use an Android.
You're Apple dudes?
I'm also an Apple dude.
Sorry,
I use an Android phone.
Let's be clear on this. It's important. Yes?
So I'm an Apple dude.
Apple dude?
Yes, yes.
Apple dude.
Apple dude?
Yeah.
All right,
It's
Jill.
official term. That
Jill,
was fantastic.
You were right. Good session.
I am so proud of you. Is it lame if I say I'm totally proud of them and they're not mine? Fantastic. I should only hope that Brody this is waning up into our bedroom right now. That's fantastic. Fantastic. Thank you so much.
All right.
Fantastic.
Thanks, guys.
Bye-bye.